Welcome to After the Fact. I'm Dan LeDuc for the Pew Charitable Trusts. We're bringing you an extended conversation now with Sudip Parikh, the CEO of the American Association for the Advancement of Science, whose mission is to advance science, engineering, and innovation throughout the world. AAAS, as it is known, was formed in 1848 as a way for scientists in the United States to get together and talk about their work. And it's evolved to include publishing a half-dozen journals, including Science, the premier weekly in the field. A biochemist by training, Parikh left his lab coat behind for a career that seeks to improve the intersection of science and society.
There was a point in my life where I could spend 6 months pulling together experiments to answer a question, and those 6 months would be drudgery. But there was a moment of discovery, even if it was a small discovery, that really made all of that worthwhile. And I really enjoyed it. And I became an expert in one molecule that is inside of the human body. And at some point in my career, I really wanted to expand out beyond that one molecule.
I'm sure it's a very important molecule.
It's a very important molecule. Uracil DNA glycosylase. I'm happy to talk about it. But what I found is that I really enjoy this place where the science meets the rest of the world. Because one of the things that I've seen over time is that science itself is beautiful, but when you can take that beautiful science that inspires awe and then have it become part of the world at large, it makes a gigantic difference in many, many more people's lives. And I found that rewarding.
Yeah, and that notion that science is beautiful, that's a lovely way to say it, and interacts with society, should seem obvious, right? I mean, you and I are talking via the internet. We take medicines. We're in the middle of an incredible pandemic. Science is all around us, yet we sort of feel at least the need to point out that there is this connection, that we have to talk about this connection with science and society when it seems obvious. Why isn't it obvious to some people?
Yeah, I think that to some degree, success has been our worst enemy, right? Because success means that you don't see some of the sausage getting made that maybe you used to see. And what you really see is this, instead of talking about the internet, you don't see the messiness behind it. You see these wonderful, sleek user interfaces that anyone can use. And it creates a separation between the science itself and the end user of that science, in much the same way that in the 1970s and 80s we started to complain that children didn't know where their food came from. It's that separation that takes science and puts it in somehow separate from the rest of things, and it's not. How
do you personally and the organization fulfill this notion of trying to help people better understand this connection?
Yeah. For AAAS, that has become building trust and relationships with influencers in our community. And so I can walk you through some examples of that. The AAAS sponsors fellowships for scientists who are working in labs to work in policy settings, so to work in Congress, to work in the executive branch, and to bring their scientific thinking and their scientific experience into that policy realm. Because they're trying to build relationships with people that are making policy. We also have programs like that for journalists. So we have scientists who work in newsrooms, and very importantly, at local papers in smaller cities around the country, and local TV stations around the country, because that is where people get their information. You have to build trust with those influencers. We also have a program for seminarians. So that might not be the most intuitive thing, but it turns out that if you build trust early with seminarians, with people of faith, that even when there's disagreement, there's a level of trust and a relationship that you can build on later when it becomes important to build on it. You have to build that trust beforehand, not when you need it.
Right.
And so that's what AAAS tries to do, is build those bridges with influencers in our society.
Let's talk, though, about trust. Pew Research Center polling shows that the public's trust in scientists is perhaps not as high as we would have expected it to be. What do you attribute that to? I mean, you're working to improve it, so why is it where it is?
Yeah, science. When we hold up a mirror to ourselves as scientists, we have made mistakes, right? So I think you have to look backwards a little bit and say, what got us to where we are today? And if you're from the Black community, you know about Tuskegee and the ethical violations that took place in that human subjects research. You know about eugenics. You know about some of the areas where science has had challenges with itself, as society has. And so we have to be able to hold up that mirror to ourselves and say, it's not that science is a human endeavor. It's fallible. And so we have to make sure that we are building those human interactions, those human trust points, so that people realize that the person they're talking to is a scientist, but they're also a member of their community. And that member of their community has the same wishes and hopes for their children as they do. And that they're going about it in a way of looking at research, looking at evidence to try and answer questions, to guide individual decision making. And they're willing to share that with me, a trusted person in the community. And that has eroded over time as science has become much more removed from the everyday practical. You know, in the 17th century, if you wanted to be a scientist, you could be a scientist. Everything that was known could be found in an encyclopedia type of book. It's not possible today. And so when now science is removed because the necessity of speaking with precision creates jargon, and jargon takes it completely out of the realm of the lay public. And so it becomes a special skill set to be able to break out of the audience of scientists and break into the audience of the interested, of the allies of scientists, of the general public. And that becomes a skill set all its own.
I want to talk about that in a moment, but first, of course, we can't go any further without saying we're having a conversation in the middle of a pandemic, in which the public is turning to science. They're actually, the numbers actually show great trust in our government agencies that are based in science, like the CDC, and that's encouraging. How good a job have scientists been doing now and in getting that message out of what we know and what we don't know about the virus?
It varies across even our great land, right? So we have 50 states, and each of those states has had a mini version of what we're seeing at the federal level, with a chief scientist or someone in charge of a public health organization standing beside of a governor and providing this information. And it has varied across the country. And I think it's varied for several reasons. One being the support given by the leadership, the political leadership. If the governor trusts that person who's standing beside of them, it shows. It shows, and that there's a relationship there. And suddenly the people who are supportive of that governor will transfer some of that respect and credibility to the scientist standing beside them. The challenge has been explaining to people that the science is evolving very quickly on these coronaviruses and on COVID-19, and that can mean that there are changes to the way that we talk about it, changes to the recommendations, and that there's uncertainty. People want certainty, and sometimes science doesn't have certainty to give you. And being honest about that can be hard for a scientist. You know, in the same way that it's hard for a doctor, it's hard for a scientist. And so where we've fallen down is when we haven't been as clear about the uncertainties that lie in front of us, and that we don't know. We don't know. There are things that we don't know, and there are things that we don't even know that we don't know. And this is hard to get across. And again, it requires building trust. That said, you know, we did convince a nation of 350 million people to shut down for several more than several weeks, several months. And so the thought that could be done and really be done at 50 different states, not at the national, but with 50 states, is pretty extraordinary and shows that there is a willingness to listen to the science, even when it's not what you want to hear.
You know, it feels like the pandemic in some ways has sort of opened the curtain a little bit on the scientific process, right? I mean, because science is this ongoing process of discovery. Sometimes we think we have a discovery and it's not that. It's this constantly evolving thing. And I think for a lot of lay people, we sit back and we pick up our newspaper or turn on the TV news, and there's this new discovery that scientists have found a new planet. They have found a new drug. And we think that it's this process that leads to this goal, and now we're moving on to something else, when in fact, your brother is out there doing this on a daily basis. And now we're all living it because of the pandemic.
Exactly. We're living it in real time, right? And so if you're not a scientist and you're watching in real time, as different papers from different groups get published talking about the positivity rate for COVID-19 in the general population, and you're seeing disagreement, you think that there's something wrong. But as scientists, we see that as something right, that it's telling us something, that there's a difference. It's either telling us that somebody has, that there might be something systemic in one of the papers, or it might be that, frankly, the methodology that they used is producing different results. Why is it producing different results? That matters. That why matters. The problem is that we don't have a neat story to tell you all at once, or we're doing it in real time. If I could write the story of COVID-19 in 2 years, 2 years from now, I could probably wrap it up into a nice, lovely little story that has a beginning, a middle, and an end. We don't get that luxury. This is science in the service of society, and it's messy, and it's going to be messy, and it requires. Again, it requires this relationship building and trying to build trust in a way that we've never had to do in real time before, ever.
And that's going to lead to people getting advice. Initially, were the masks important? Now we know they are. And something else is going to change probably as this progresses, as well as we learn more. Do you think that these facts get transmitted in ways that really do help people understand what's going on, or could scientists be doing more to sort of break through some of the confusion?
We can always do more. This stuff is so confusing, and so I saw a wonderful thing on Twitter, which is of course the place where we all get our information these days. There's lots of studies about masks now, and someone did a wonderful little experiment. It's so visual. They took some petri dishes, they put a mask on, and they sneezed toward them, right? And then they sneezed toward them without a mask, and they showed what grew on it after a night in an incubator. And it's very visual, very telling that, look, the one where you wore a mask has less on it than the one where you did have a mask, or where you didn't have a mask on it. That kind of ability to break down this difference between, yes, there is precision involved. The scientific study has a whole bunch of different trials, and there's statistics, et cetera. That visual is not a precise experiment, and frankly, would never hold up in a scientific journal. But in communication, the accuracy that is in that image is more important than the precision of being able to say, with specificity about the percentages and statistics and the number of trials that you did, all of that. And so that's where we as scientists have got to be able to do both those things at once in real time right now.
Well, and so much of the applied science side, isn't that sometimes serendipity, right? And because that's also part of this wonderful process of science. Like you're plodding along, thinking you're going in one direction, and you find this new signpost that tells you something that you weren't even looking for.
Absolutely. There's an old story about Michael Faraday, and he's asked by William Gladstone in the UK, why are you researching this basic research around electricity? This is around the turn of the 19th century. And Faraday says back to him, I'm going to paraphrase here, sir, someday you'll be able to tax it. And boy, was he right. This is the basis of our modern economies is on electricity. But at the time, the thought of, it seemed very impractical to be studying what an electron is. And so we know that the things that, we have faith that some of the things that we're researching now are going to have that same kind of an effect on our society. And we've seen it over and over again in the biological sciences. In the 1980s, there were scientists who were looking at these little repeats in DNA and in RNA of the letters A, C, T, and G. And little did they know that in the 2000s, 2012, this would be identified as a way of making mutations in DNA in people called CRISPR, and that CRISPR has the potential to cure genetic diseases, all based on this work that was so basic at the time in the 1980s that frankly it would have had a hard time getting funded. But here we are, and now it's the basis for a cure for sickle cell disease, a cure for beta thalassemia, and many other genetic diseases. So we don't know where those stories end, but we do know that that there is this almost magic that happens when basic research combines with other infrastructure and again the brains of people. These are human endeavors, and we need those. We need people with a diverse set of eyes.
So you have almost a unique perspective and platform given your job, right? To see this overview of science and where it can intersect with policy. So for the rest of us who sort of have to rely on news and whatever our friends tell us about developments because we don't have that perspective, what excites you right now about this time, and what's going to be happening in the next 10 years that we can be looking forward to?
Yeah, I look at it I put it in two buckets. One is this thing about awe-inspiring. There are things that we learn that just make it gives me goosebumps. It gets my kids excited, and that's so. Let's talk about those first. In the next decade, some of the biggest telescopes ever are going to be coming online. We're talking about meters and meters of reflective mirrors, and they're going to see things that we've never seen before. And so we're going to see we're going to be able to look at the atmospheres of exoplanets, so planets outside our solar system. And what if we see methane in the atmosphere of one of those? What that means is methane it doesn't necessarily require life, but boy, it takes some circuitous routes to get there if it's not life that's making methane. So what if we see that?
That means there is a chance for life out there.
There's a chance for life out there, and there's a chance that we could even see it. The fact that from 11 light years or 50 light years away that we might be able to detect a telltale sign of life is extraordinary, right? It's just absolutely extraordinary. So that's one. We have in this instrument called LIGO and another one called Virgo these new types of basically telescopes that can see gravitational waves, and they've already just in the past couple of years seen things like black holes running into each other, and what that creates is a wave in gravity that we can measure now. And that's opened up, it's as if we had a new type of eye, right? We have a new eye on the universe that we can point out there. It's the equivalent of Galileo looking through the telescope. And so we're going to be doing that over the next 20 years. And I don't know what we're going to see. That's going to be remarkable. So in the awe-inspiring category, I put that. I also put that we're going to be able to see the oceans in a much more detailed way, deeper than we've ever done it. Less people, there's the old, there was the old thing that said that less people have been to the bottom of the ocean than have been to the moon. That's not true anymore. Just in the past couple of weeks, we just passed 12 people having been to the bottom of Challenger Deep.
That's a headline right there.
It's a headline. It's a huge headline. And what's going to happen now is we'll be able to we actually can reach any point in the ocean now with people and with sensors. And so we can see the kind of life that's down there. And what we're finding is, hey, there's no sunlight down there. So how are things growing? Where's the energy coming from? And of course, it's coming from chemical processes. Well, that's a great way to have life anywhere. It's Europa or other places in the solar system. So we just have this opportunity for awe-inspiring discovery that is out there. The second bucket that I put these things in is things that have benefit to humanity and that could really change our lives. And these can be awe-inspiring too, but in a way that's much more in our neighborhood. So I'll talk first just about cures to diseases. We never talked about cure. As scientists 20 years ago, if you said the word cure, that was irresponsible. We really didn't have cures for much of anything. We could treat things, and we did pretty well at it. We'd done a pretty good job. We never cured anything. We are in an era where those technologies that I mentioned before, like CRISPR, regenerative medicine from stem cells, they're coming to fruition. They're coming to fruition, and we're seeing in clinical trials. There's a woman in Mississippi right now who has had a CRISPR done to her cells, so mutated her cells. She used to get a transfusion almost every month, a blood transfusion every month, because of the pain caused by her sickle cell anemia. And right now, today, she hasn't had a transfusion in months since she got this treatment. And at some point that becomes a cure. It's not just a treatment; it's a cure when we get far enough along. So, look, it has to get to scale. There's lots of hurdles still in the way, but there are real opportunities for cures in the next decade. There's also opportunities for advancing the way that we communicate with one another around the world. Because of the opening up of low Earth orbit to commercial enterprises, we just have this ability that the cost is going to go down even further in communication. And that's already changed the world, because the world is flat. There are great minds everywhere. And that next person who is going to cure a disease or who is going to find a planet with methane might be living in Tanzania right now or in Rwanda right now.
During this pandemic, what have you found as a scientist yourself, sort of just personally interested to watch? I mean, what are you following during this time? What are the developments that you want to learn more about?
As a scientist, and I'm speaking as a scientist here, not as just my normal self. So as a scientist, what I've seen is this incredible speed of discovery about COVID-19. So when HIV first came on the scene, the time from isolation of the virus to the amount of information that we have about COVID-19 now was years, if not decades. In the span of 3 months, January to March, we went from isolating this virus to seeing the atomic resolution structure of the spike protein that is what's binding into people and what should be the target for antivirals. In 3 months. In 3 months we got there. In 6 months, we know more about the pathology of this virus than we do about many, many others that have ever come before it, because what you saw was the entire scientific enterprise pivot to this one thing as quickly as it possibly could. You're seeing papers in physics journals about the atmospheric science of water droplets coming out of your mouth. This is extraordinary. We've never seen that before. So I think that shows you what's possible. It shows you that institutional change can happen overnight.
Let's put sort of the immediacy of the pandemic aside and talk more generally about the times we live in today, say compared to a generation ago. Science obviously shapes us, but I'm curious your view of how this time that we're living in shapes science.
20 years ago, we might not have taken that paper about income inequality. We might not have taken the paper that leads to a discussion about health disparities. But what we see is that this moment where this coming together of social justice, history, and science in the COVID era has made it to where we realize that those gatekeeper functions that we have got to evolve. They have to evolve so that we have people looking at the science through many different prisms of their experiences. And so this wonderful, I've got a picture of the building here behind me on the screen. This monument to science, there's tons of pictures in there of the scientists of the past. And they did wonderful things, and we stand on their shoulders. But we're about to enter a new era where we need, how do we build on that? How do we build on that foundation? And what this time is creating a moment where we can actually grow the types, number, and diversity of minds. And I'm not just talking about racial and ethnicity and gender. I'm talking about where people are from and how they think. And we have an obligation in this generation to do that, because frankly, if we don't do it now, when are we going to do it? The society is telling us to do it. They're kicking us in the pants to do it. We have to do it now.
Thank you for listening. I'm Dan LeDuc, and this is After the Fact from the Pew Charitable Trusts. To hear more conversations on science, please visit pewtrust.org/afterthefact.